solve it is to bring this fraction over to the right, since the right hand side is equals to 0, and then we are able to get this, such that it allows us to do cross multiplication. Right? This is the skill that we have learned in Set 1 when dealing with equations that are in fractional form. Okay? The thing that we want to look at today is part A, whereby we have a minus 3 over 2 plus 2a minus 1 over 7 equals 4. In this case, it is not as straightforward because I can't actually bring this fraction over to the right such that I'll be able to get or fulfill the conditions for us to do cross multiplication. Because if I were to bring this over to the right, what happens is that I'm going to get 4 minus 2a minus 1 over 7. Okay, I'm not trying to say that we cannot solve it. It can still be solved if I were to arrange it in this manner. Okay, just that we need to do certain things first before I can do my cross multiplication. Because if I want to do cross multiplication, the conditions that must be satisfied is that I must have a single fraction here and a single fraction here so that I can cross multiply in this manner. But in this case, I don't have a single fraction on the right side. Okay, I have a single fraction on the left, but on the right, it is a combination of two things. We have 4, then after that minus away, 2a minus 1 over 7. Okay, so if I want to continue from here, let's try to continue from here. What is it that we need to do? I must have single and single in order to do cross multiplication. So how do I make this problem over here on the right into a single fraction? What do you think we can do? What is 4? 4 is a whole number, right? And that's 4 over 1, right? Can I combine these two into a single fraction? Can, right? So if I want to do that, what should my denominator be? 7. And in order to get a 7, my 4 must multiply by a 7. So I will get 4 times 7, that will be 28. For the fraction on the right, I'm not going to change the denominator, but do be very careful, it's a minus sign over here. It should be a negative bracket a minus 1. Okay, so there must be this set of brackets. Because when I open up that set of brackets, I'm going to arrive at 4 times 7, 28, minus 2a plus 1 over 7. Okay, so this minus and minus equals plus 1. Okay. And now I have my single fraction versus a single fraction already. But maybe for the fraction on the right, I want to simplify that first before I do any cross multiplication. So we get 29 minus 2a. Okay. Then now my conditions are satisfied for me to do the cross multiplication. So in doing that, I will be able to have 7 times a minus 3 equals to 2 times 29 minus 2a. Right? And what will that give us on expansion is 7a minus 21 equals to 2 times 29, that is 58. Is it? Minus 4a. So our aim is to find the value of a, place all the a's on one side. And we have a to be 79 over 11. You may leave it like that, or you want to write it as a mixed number of 7 and 3 over 8 and 2 over 11. Okay. Any questions? Right? This is one way of solving. There is definitely another way of solving. What we saw here is that we brought this fraction to the right. Was it even necessary for us to bring that fraction to the right? Not necessary, right? Because our goal was to do cross multiplication So it would be a single fraction and single fraction. I can create a single fraction right from the start of the question, right? So if I were to start right at the beginning with the question, between these two fractions, I can just combine into a common denominator of 14 because 2 and 7's lowest common multiple is 14. Then I'll have 7 times 8 minus 3 plus 4 times 8 minus 1. Then I'll get this. Such that in the numerator I'll have 7a minus 21 plus 4a minus 2. Simplifying the numerator, I'll get 11a minus 23 over 14 equals 4. 4 is 4 over 1, so can cross multiply. I will get 11a minus 23 equals 4 times 4. And this will give us 26, right? So again, we get 11a equals to 79, and a equals to 79.11. Okay. So I'm demonstrating to you two ways, okay, for us to combine the single fraction so that we can do cross multiplication. Right? Are there any questions at this juncture? I want to throw in a curveball. Okay, I want to throw in a third method. Right? Okay, third method is slightly trickier. You must be aware of what you're doing. Okay? This is a third equation. Sorry, this is a not third equation. This is a what do I want to say? This is an equation. Okay, sorry. Something just came to my mind. Okay. So in this case, this is an equation, right? Okay, I can balance an equation by multiplying on both sides, subtracting on both sides, divide on both sides, or add on both sides. Correct? So in order to balance an equation, I must do a certain operation on both sides. Okay. The problem about this question is that there are denominators. It is a fraction, and we don't enjoy dealing with fractions. Okay? But the thing about equation is that I can somehow get rid of the denominator by multiplying by a certain number. Okay? On both the left side and the right side. Okay? So what is this magic number that I can multiply with that will be able to get rid of all the denominators that I have? That will have to be 0. 0, then the whole thing becomes 0 again. I'll multiply by 14 because 14 being the lowest common multiple of the denominators, okay, I will be able to get 14 times a minus 3 over 2 because when I do my expansion, it will look like this, plus 14 times 2a minus 1 over 7. And then 4 times 14, that is 56. Okay, I'm doing intentional steps over here. Of course, if you understand it, you can reduce certain steps. So when I do my expansion, 14 times this, okay, 14 I can divide by 2, I will get 7. And then after that, 14 divided by 7, I'll get 2. Okay, so when I multiply across by 14, I'm actually multiplying every single term by 14, such that I'm able to get rid of the denominator and be left with the factor of 7 here and a factor of 2 here. So in this method, I can immediately jump into this numerator without the denominator. So it's actually a faster step. Okay, you're doing a lot of things together at the same time. Okay, then we expand this, you'll get 7a minus 21 plus 4a minus 4. 8 minus 2. I will always stick to combining into single fraction, then you cross multiply. Okay, because I might be prone to mistakes when doing this. But that's just myself now. Okay, I'm just careless in nature also. Yes. Any questions? If not, I want you to try on your own. This topic not much, they only give you one practice now example. Okay. I want you to try exercise 6B, question 3, page 143. Just do part D. The problem about this question is that the denominators are not numbers. Okay, so will the method still work? Especially this the method that I showed you. Right, I give you about 10 minutes for that. For 3D, let's look at Rose's answer. Okay, I think generally 3D, most of us can get it as a walk around. Okay, most of you decided to just happily take this fraction moving to the right, okay, and then do your cross multiplication. Okay, I don't see it as a problem for most of you. So, doing the cross multiplication, this set is correct, and do the expansion. Okay, then after that we get E to be equals to 6. Okay, most of us are able to get that, right? Okay, so plus 10 versus root. Okay, let's get 3G. Interestingly, all of them presented it in slightly different manners now. Okay, let's look at what Evan has given us for 3G first. Okay, I have concerns regarding the presentation. Okay, why? Look at this presentation over here. Okay, as a first time reader, what do you see this as? X23 over X2K plus 1. Okay, but of course I think we know what it's trying to mean, right? It's trying to refer that the numerator times 2, okay, and then the denominator times 2. Right? So I would recommend that maybe the times 2 use it as a factor to write, okay? Otherwise don't write it at all. Because it looks like it's X23 and then X2K plus 1. Okay, so a lot of meanings being misrepresented. Okay, so therefore please don't present it that way. Okay, so what he's trying to do is to achieve the same denominator, 2k plus 2. Okay, because he sees that 2k plus 2 is a multiple of k plus 1. Right, and so that okay, once we get the same denominator, we take numerator minus each other, 6 minus 1, that's 1 gets 5. Okay, then after that we did the cross multiplication, hence getting the negative half. Okay, so the answer in general, okay, with the concept is actually correct. Not a problem, except for this presentation. But for this presentation problem, I will minus 5 points now. Okay. Now let's look at 3G from Hansheng. Okay, Hansheng decided that, okay, in making the same denominator, he just happily take the two denominators and put them together. Okay, is that the correct way to do it in creating a single fraction? No, right? Because we should always be trying to get the lowest common multiple. Okay, so I don't want to encourage this process, right? Because it isn't quite right. Although in the end it's kind of self-rectified because in this case here, this 5k plus 5 would just be factorized as 5 times k plus 1, and then your k plus 1 can be divided away. Why I don't want to encourage this, okay, is because it will become a problem when we go up to second 3, right? When you always think that denominators just multiply each other for common denominator. That is not a correct concept. We should be trying to get lowest common multiple. Okay? Because when you do this, you might run into a situation where you end up solving a quadratic equation, which shouldn't be the case exactly. Okay, and then if you're in Set 3, you might run into a situation of solving a Curie equation, which is another skill on its own that we learn in A-maths instead. So I don't want us to be confused. I want us to be aware that the aim that we're trying to drive for in creating a single fraction is for lowest common multiple in the denominator. And in this case, it should be like whatever that's done 2k plus 2. Okay? Then after that, getting the negative half over here. So for this concept over here, I'll also minimize my points up. Okay? Although generally in exam you still get a mark, but I don't want you to have this kind of concept. Okay? 3G itself from Xavier. Okay? Also getting negative half is the answer. Okay? But there is a big problem in terms of the presentation. Okay, where is this big problem? It is here. Okay? I think we all understand what he's trying to do also, which is what Evan was trying to do times 2 on the top times 2 at the bottom. But when you write it this way, what does it actually mean mathematically? When you write it this way, it means 2 over 1 times 3 over k plus 1. So actually it is numerator times numerator, denominator times denominator. It should actually just be 6 over k plus 1. Okay? Not a 6 over 2k plus 2. Okay, so conceptually this is an incorrect presentation, which will definitely cause a loss of marks. Okay, because incorrect method. Answer although correct, but incorrect method, no matter mark or answer mark. Okay, so therefore this is not a correct presentation at all. Okay, so I will also minimize my points up. So each of these group get 15 points each. Okay. Right, any questions? Okay. For 7D, I think I'll just leave it for the next lesson to run through. Okay. However, I want to add on to your homework. Okay. We have a homework due on Friday already for exercise 6B. I want to give an exercise 6B part 2, which will consist of just question 3A, 3C, 7A, and 7C. Okay, this shall be due on WA already now. Wednesday, right? And it be due on Monday. Would it be okay? This one due Monday. Okay, next Monday, 22nd April. Then after